Hello students, myself Dr. Divya Ghildayal. Hope you all went well with the question paper which came on the 29th of July 2020. Here presenting to you the complete solution of your engineering physics paper. As you can see, the total marks of the paper were 100 marks and it was a 3-hour paper. You had to attempt all sections and they have not given any constants in this question paper. Here they are saying that you will assume any missing data on your own. Things like mass of electron, mass of photon, Planck's constant, etc. This type of constants are missing from the paper. Approximate marks are allotted to each question. Accordingly, you have to write the answers. Let us begin. See, section A paper, attempt all of the following questions in brief. As you can see, section A is carrying 2 marks for each question, and the questions are from 2 questions from each unit. Let us begin. What is frame of reference in motion? First, you will be defining frame of reference, that it is a standard relative to which motion and rest may be measured. Any set of points or objects that are at rest relative to one another enables us to describe the relative motion of bodies. And 1 mark you will get when you will draw this diagram with frame of reference, showing one as the inertial and the other as non-inertial, moving with velocity v. Next question, show that massless particles can exist only if they move with the speed of light and their energy and momentum have the relationship E is equal to PC. Now, 2-mark question. A particle which has 0 rest mass is called a massless particle, and in classical physics, massless particle does not exist, but in relativistic mechanics, a particle with 0 rest mass exists from the relationship E square is equal to P square C square plus M naught square C to the power of 4. If I put rest mass equal to 0, I get E is equal to PC. So I will be getting 1 mark for deriving this expression and 1 mark if I show that if P is equal to momentum mv and V is equal to C, that is velocity of massless particle comes out as same as light speed of light in free space. Next question. This is from EMT. In an electromagnetic wave, the electric and magnetic fields are 100 volt per meter and 0.265 ampere per meter. What is the maximum energy flow? From Poynting vector, we know that S is equal to E cross H. In this question paper, Poynting has been asked twice. There is another 10-mark question based on Poynting theorem. You have been given E as 100 volt per meter and H as 0.265 ampere per meter. You just have to cross multiply both of them to get the answer. Define the concept of skin depth for high and low frequency waveforms. Skin depth is that distance below which the surface of a conductor, when the current density has diminished to 1 upon E times of its value at the surface. And skin depth is inversely proportional to the frequency, as you can see in this formula. Hence, since the relationship is an inverse relationship, when one quantity will increase, the other will decrease. You get 2 marks for writing this. 1E. What is Compton effect and Compton shift. So 1 mark for Compton effect, demonstrates that light cannot be explained purely as a wave phenomena. When a photon collides with an electron at rest, the photon gives its energy to the electron, and the scattered photon has a wavelength higher compared to the wavelength of incident photon. This shift in wavelength is known as Compton shift. If you want, you can write the formula H of a change in wavelength, and you will be getting 2 marks. Why is black the best emitter? Black colored objects absorb all the wavelength of light and do not reflect any of them. Hence, it looks black in color, and it is considered to be a good absorber and a good emitter of heat. Why is the center of Newton's ring in reflected system dark? The central fringe in Newton's ring is dark because the air film thickness formed at the center between the glass plate and the lens is 0. Hence, at geometrical path difference between the incident and reflected rays from the glass plate is 0, giving us the condition of minima, and I will be getting 2 marks for this. Explain the Rayleigh criteria of resolution. Rayleigh criteria of resolution: 2-point sources are resolvable by an optical instrument when the central maxima in the diffraction pattern of one falls over the first minima due to the other, and vice versa. If you want, you can even draw the diagram which I told you when I was explaining you this unit. What do you mean by acceptance angle and cone for an optical fiber? But as you can see, the question paper is strictly telling you to only write after seeing how much marks are there for that question. So if it is just a 2-mark question and it is asking you the definition, then just give the definition. So acceptance angle is the maximum angle at which the incoming sunlight can be captured. The cross section of an optical fiber is circular. The light waves accepted by the core are expressed as a cone. Define spontaneous emission and stimulated emission. Spontaneous emission 1 mark, stimulated emission another 1 mark. So spontaneous emission is the process in which a quantum mechanical system transits from an excited energy state to a lower energy state and emits a quantized amount of heat in the form of a photon. And stimulated, the condition necessary for laser action, is the process by which an incoming photon of a specific frequency can interact with an excited atomic electron. Now let us come to section B. Here I have to attempt any 3 questions. Each question is carrying 10 marks. And the breakage of this 10 marks also I will explain you. Look at this question. What, and obviously each unit has been picked up from the while framing section B. So you will be coming across all 5 units 10 marks each. What is the special theory of relativity? Derive Lorentz transformation equation. Special theory of relativity, if you explain, you will get 2 marks. That is how speed affects mass, time, and space. This theory includes a way for the speed of light to define the relationship between energy and matter. And when you derive the Lorentz transformation equations step by step, you will get your remaining 8 marks. And at the end, you will write that these are the Lorentz transformation equations. Numerical. Assuming that all the, this is again based on Poynting theorem, that all the energy from a 1000-watt lamp is radiated uniformly, calculate the average values for the intensities of electric and magnetic fields of radiation at a distance of 2 meters from the lamp. We know from Poynting theorem that let P naught be the total power radiated, and then the energy will be given by P upon A, that is area. Now this is a lamp which is radiating uniformly. Hence, I will take it in the form that the light emitted is coming in the form of a circle. So I will write the formula for sphere, 4 pi r square, surface area of a sphere. R here is given to me as 2 meters, and from Poynting theorem, S is equal to E cross H. E and H are perpendicular to each other, 90-degree angle, hence S is equal to EH. So EH is equal to 1000 upon 4 pi into 4. 2 square is 4. So 4 fours are 16. And my formula E upon H is equal to under root mu naught upon epsilon naught is equal to approximately 377. I have two equations. I have two unknowns, E and H. Either I multiply both of them or I divide both of them to solve the individual values, and I get my answer as E is equal to 86.59 volt per meter and H is 0.23 ampere turn per meter. And this is how I will fetch 10 marks for this numerical. Next numerical, calculate the energy difference between the ground state and the first excited state for an electron in a one-dimensional rigid box of length 25 angstrom. For writing this formula, En is equal to n square h square upon 8 ml square, I will get 2 marks. For putting the numerical value, question paper has not given me the numerical value. I have to put them on my own. So H is 6.63 into 10 to the power of minus 34 joule second, mass 9.1 into 10 to the power of minus 31 kg, and length I have been given in my numerical as 25 angstrom. I will convert this angstrom into meter by multiplying it by 10 to the power of minus 10. Putting these numerical values in this expression above, I will fetch another 3 marks. Then I will change this into electron volt by dividing it by 1.6 into 10 to the power of minus 19. And which two energy levels are they asking me? N equal to 1 and N equal to 2. So accordingly, I will put N equal to 1 and I will get the energy value as 0.06. And for N equal to 2, I will get 0.06 into 2 square is equal to 0.241 electron volt. And this will fetch me 10 marks. I have to be very careful when I solve such numericals because every step here is carrying marks. Next, Newton's rings are observed in reflected light of wavelength 5900 angstrom. The diameter of 10th dark ring is 0.5 centimeter. Find the radius of curvature of the lens. Diameter is given by dn square is equal to 4n lambda r. So r becomes equal to dn square upon 4n lambda. If I write this formula and I tell what the terms stand for, like lambda is wavelength, dn is diameter of the nth ring, n is the diameter of that ring which I am talking about, then I will get 2 marks. Then I will put the numerical values which have been given to me in the numerical and make the conversion system uniform. That means here I have been given 5900 angstrom. I will change this into centimeter and I will put 59 into 10 to the power of minus 6 centimeter. N is 10. Till here, I will be able to fetch 5 marks. Then I will have to use either a calculator or solve it numerically to arrive at my answer. R is equal to 105.9 centimeter. A step index fiber has refractive indexes of 1.466 and 1.46, which are refractive indexes of the core and cladding. If the operating wavelengths of the ray is 0.85 micrometer and the diameter of the core is 50 micrometer, then calculate the cutoff parameter and the number of modes which the fiber will support. Cutoff parameter is given by V is equal to pi d upon lambda naught under root n1 square minus n2 square, where when I write this formula and I explain the meaning of each symbol, I will get 2 marks. I will then put the numerical value given to me in the question. If required, I will make them all uniform, but in this case, I am noticing it is micrometer on both ends, so I don't need to change the unit. I will put the numerical values in this formula and I will get the answer for cutoff parameter. For number of modes, V square upon 2. I will fetch another 4 marks. So this gives me 10 marks for this numerical. Next, what was the object of conducting? This is section C. Here, I have to answer any one of the following. I have been given choice here in this section. So 10 mark question from each unit. Objective of conducting experiment and to illustrate the experiment in detail and state its outcomes. So what was the objective of conducting Michaelson-Morley experiment? The objective was to detect the velocity of Earth with respect to ether, a hypothetical medium. And the experimental setup consists of 2 glass plates, 2 plane mirrors, path difference was formed, and the number of time taken by the ray of light in going, coming back, and then from the path difference, we found out the formula for fringes, and putting the experimental values in this path difference formula, we got a numerical value of 0.2 for the fringes. But this experiment failed when it was performed at different seasons of the year. And negative results which came out was that ether is undetectable and it suggests that speed of light is same everywhere. And the conclusion is that it is impossible to measure the absolute value of the Earth with respect to ether frame. So till here, I will get 10 marks. Einstein mass energy relationship and evidence showing its validity. So from Newton's law, I know that force is equal to dP by dt, where P is momentum and work is force into displacement. I put the numerical value here using the expression for relativistic mass m equal to m naught upon under root 1 minus v square by c square. I get my expression for energy as E equal to mc square. And experiments which have proven this are the very basic nuclear reactions where we use the formula of del E equal to del mc square. That is the very basic formula which proves the existence of this. Next question from unit 2, deduce Maxwell's equation for free space and prove that electromagnetic waves are transverse in nature. I will get 2 marks if I write the Maxwell's equations in free space, and another 8 marks pending I will get once I prove that they are transverse in nature by deriving the expression. Define radiation pressure and momentum of electromagnetic wave. Radiation pressure, this again definition will fetch me 2 marks, that the rate of change of momentum is equal to the force. This force acting on the unit area of surface exerts a pressure called radiation pressure. And in order to derive the expression, I will be fetching my remaining 8 marks. What is physical significance of wave function? Derive Schrodinger's time independent equation. For writing physical significance, I will get 2 marks, and for deriving the Schrodinger equation, I will get my remaining 8 marks. So the wave function is basically a complex valued probability amplitude, and the probabilities for the possible results of measurements made on the system can be derived from it. And then I will derive my Schrodinger wave equation. What is Compton effect? Deduce an expression for Compton shift. So the Compton effect defines that wavelength change is found upon scattering, which is given by del lambda is equal to h upon m naught c into 1 minus cos phi. And in order, this will fetch me 2 marks. Remaining 8 marks I will get when I derive this expression from the principle of conservation of momentum. They will give me my 8 marks. What is Rayleigh criteria of resolution? How can one increase the resolving power of a diffraction grating? Using Rayleigh criteria for resolution, show that resolving power of grating is equal to n into n. So Rayleigh criteria, what it states, I will get 1 mark. Resolving power can be increased by increasing the number of lines per meter on the grating. I will get another 1 mark. And resolving power formula, when I will derive, which is equal to n into n, I will get my remaining 8 marks. Discuss the phenomena of Fraunhofer diffraction at a single slit and show that relative intensities of successive maxima are given by this series. So I will draw my diagram for single slit. It can fetch me 3 to 4 marks if I label the diagram properly by labeling the lenses, screen, slit, etc., the monochromatic source of light. Then my path difference formula leading to phase difference formula and the expression for intensity. After that, I will find the maxima and minima of this intensity expression here, and I will put the numerical values for sine wherever I get my maxima, minima, and I will get the series. Okay. A silicon optical fiber with a core diameter large enough has a core refractive index of 1.5 and a cladding refractive index of 1.47. Find critical angle, numerical aperture, and acceptance angle. Formula for critical angle is sine inverse mu2 upon mu1. Here, mu2 is 1.47 and mu1 is 1.5. So I get my critical angle as 78.5 degree. This can fetch me 3 to 4 marks. Numerical aperture formula, under root mu1 square minus mu2 square. I put the numerical value of mu1 and mu2 here, and I get my remaining 3 marks. 0.30. Acceptance angle is sine inverse of numerical aperture. Numerical aperture, I have found 0.3. So I find sine inverse of 0.3 equal to 17.4 degree. This way I will get 10 marks for this numerical. What do you mean by population inversion? Describe ruby laser in detail. Population inversion is when an upper state system has larger photons compared to the ground state. It is a necessary condition to achieve laser action. I will get 2 marks for that. For drawing a neat and clean, well-labeled ruby laser diagram, I will, and explaining its functioning with an energy level diagram, I will get my remaining 8 marks. So students, best part was if you compare this paper which came with the model paper which was floated on our channel 5 days before your final exam, 80% of the questions have been coming from the model paper. Rest, you can see the difficulty level of this paper was moderate, And I will say it was not very difficult also and not very easy. It required lot of writing work. So hope you did well in the paper. Thank you.